In 6.5, we had filled out the, I want to say XY chart. That's not an XY chart. It's an R theta chart, or theta R chart, on number 2, and we're ready to graph it, yes?
Yes.
So, you guys have your values in front of you. I'm going to go to my graph page. Now, unless you can squint really well and read those, you probably need to put some labels on here so that we know what we're doing. So here's 0. First quadrant is pi over 6, pi over 4, pi over 3. At 90 degrees, we call it pi over 2. In the next quadrant, it's all 1 before pi, so it's all 1 before a whole pi. So 2 pi over 3, 3 pi over 4, 5 pi over 6, and then we're at that whole pi. Bottom quadrant 3, now we are all 1 past 1 pi. So 7 pi over 6, 5 pi over 4, 4 pi over 3. We know 270 is 3 pi over 2. And this last quadrant, we're all 1 before 2 pi, yes? So 5 pi over 3, 7 pi over 4, 11 pi over 6. Okay, you ready to start graphing? Yep. 0, 2. So at 0 degrees or 0 radians, we go out 2 circles, 2 rings, 2 radii. Pi over 6, square root of 3. So we are going out 1.7. Ballpark it. Pi over 4 is 1.4. Pi over 3, 1. Pi over 2, 0. 2 pi over 3 is negative 1. Okay, are you with me? Here's 2 pi over 3 in quadrant 2. Negative 1 does what? Goes backwards. Now we're on 5 pi over 3, yes?
Yes.
3 pi over 4, right there. Negative square root of 2 shoots us backwards. We're on 7 pi over 4 at our negative 1.4. 5 pi over 6 has negative square root of 3, so go backwards. We're on 11 pi over 6 with our negative 1.7. Pi is negative 2. At pi, shoot backwards through to 0, negative 2. What just happened? We're at that same dot. Now, I would never just automatically assume that these are all going to repeat. I would do a quick visual check. Do they often all repeat at this point? Yes. Often. But don't assume so, okay? Because that can get you into trouble. So 7 pi over 6, negative square root of 3. 5 pi over 4, negative square root of 2. 4 pi over 3, negative 1. 3 pi over 2, 0. 5 pi over 3, 1. I got so used to doing negatives, I confused myself for a moment. 7 pi over 4, square root of 2. 11 pi over 6, square root of 3. And 2 pi is 2. What do we have here? Looks like a circle, yes? Just in a different location. Okay? And that is one you can graph on the calculator, right? Which, do you have your calculators? Because you're going to need them to do the math on these next couple of ones.
How do we graph this again?
Okay, so are you talking about the one we just did?
Yeah.
Okay. In order to graph this, remember you need to be in polar mode. And when you're in polar mode, it's an R equals. And so you're just typing it in. And this was R equals, what was it, 2 cosine theta? 2 cosine, and then your variable button. And then you just graph it. Okay. So if you do just like a Z standard, it looks kind of like an oval, doesn't it? But Ovals, keep in mind, often when you square them up, so if I use zoom square, number 5, it looks more squarish. I can also zoom in and make it a little bit bigger. Okay? Okay. Ready for number 3? What's the trick on number 3? We now are doing secant. Because there's part of me that says we've done 2 examples. That's plenty, yes? But secant. Okay? We have options here on how we want to do this. Okay, so what do we know secant as? Secant is the reciprocal of cosine, right? So this is the same thing as thinking 1 over cosine theta. It's also the same thing as thinking cosine theta to the -1, okay, for reference sake there. So now, 0. Well, cosine of 0 and then reciprocal it. Reciprocal it, okay? What is the cosine of 0? 1. What's the reciprocal of 1? 1. Now, and I guess over on our chart there, we have them written out. In my brain, though, just because I just know the first chart, I say, what's the cosine of pi over 6? Square root of 3 over 2, so then what's the reciprocal? And my brain says 2 over square root of 3, which is also 2 square root of 3 over 3, but we're going to want a decimal here, folks. This is where I would suggest we head to the calculators and just stay there on this one, because it's going to speed us up a little bit. What is this as a decimal? 1.155. Okay. We can do the same thing as with pi over 4. The cosine of pi over 4 is 1 over square root of 2. When we reciprocal it becomes square root of 2. Or 2 over square root of 2. Yeah, you're fine. Which is the 1.414. Okay. Pi over 3. Well, the cosine of pi over 3 is 2. The reciprocal, or 1/2. The reciprocal of 1/2 is 2. Now, those are our 3 main values we'll use over and over, aren't they? So, what about the secant of pi over 2?
0.
So the cosine of pi over 2 is 0. So what's the secant? What's the reciprocal of 0? If you have 0, say 0 over 5, and I just made up 5. The reciprocal of that is 5 over 0. You can't divide by 0, so it's what we call undefined. In the graph, in a regular graph, when we're graphing secant, remember there's asymptotes. So it's an asymptote.
Are you kidding me right now?
Okay, now it's not an asymptote on a polar graph. It's just undefined. Okay. Okay. Now, these 3 up here were quadrant 1. You could just keep putting this all in your calculator if you want. You could say, what is the secant of 2 pi over 3? I can also notice that I am in quadrant 2. What do we know about quadrant 2 answers when we're talking secant? They're going to be negative, yes? Because all students are in the sine quadrant, so cosine and secant are going to be negative. So I know they're negative. Pi over 3 is going to match up with, I just gave myself away. 2 pi over 3 is going to match up with the pi over 3 angle, yes? And so we're going to have negative 2. 3 pi over 4 is going to be negative 1.414. It's going to match up with pi over 4. And 5 pi over 6 is going to match up with pi over 6, negative 1.155. And again, we can do this because it's just doing the secant of that angle. Okay, it changes up when you throw in adding and subtracting. We'll talk about that on example 4. Okay. What's the secant of pi going to be? Yeah, cosine of pi is -1, so secant of pi is the reciprocal, which is -1. Okay. These next 3 are quadrant 3 angles. What do we know about secant in quadrant 3? They're going to be negative. So secant of 7 pi over 6, -1.155. Secant of 5 pi over 4, -1.414. And secant of 4 pi over 3, -2. What about 3 pi over 2? Okay. Cosine of 3 pi over 2 is 0. So secant, when we flip it upside down, is undefined. And these last 3 are in quadrant 4. What do we know about quadrant 4?
Positive.
All students take calculus. I don't think I ever wrote it down today, but you guys know that by now, right? So that's positive. If cosine's positive, secant's positive. So 5 pi over 3 is going to be +2. 7 pi over 4, 1.414. And 11 pi over 6, 1.155. And 2 pi is 1. That's going to go back and be the same thing as 0. Okay. With that in mind, shall we graph it?
Yeah. You're not supposed to do that.
Did you graph it on the calculator already?
No, I did it on my paper.
Oh, okay. Trying to figure out what shape we're coming up with, huh? It's different this time, isn't it? Okay. Well, let's see what you get. 0, 1. So at 0, oh, I need to label these, don't I? 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6. Okay, now let's graph them.
Yes.
Okay, at 0, we have 1. At pi over 6, 1.155. So, a little bit past the first ring. At pi over 4, 1.414. Almost halfway. At pi over 3, 2. At pi over 2, undefined. So that just means on pi over 2, there is no dot. Okay? 2 pi over 3, -2. So what am I doing here? 2 pi over 3, shoot it back through, -2. 3 pi over 4, shoot it back through, -1.414. And 5 pi over 6, shoot it back through, -1.155. Okay, where are we at? Pi, -1 makes sense, right? It overlaps, it's already there. 7 pi over 6, shoots back through. 5 pi over 4, shoots back through. 4 pi over 3, shoots back through. 3 pi over 2, undefined. That makes sense because pi over 2 was also undefined, wasn't it? So there's nothing on that line. And then 5 pi over 3 is 2, 7 pi over 4 is 1.4, 11 pi over 6 is 1.155, and 2 pi is 1. What are we looking at?
A line.
A line it is. Okay. Now, did your dots end up looking like a line? Well, who knows? Did mine? Kind of. Now, in all honesty, I also knew it was coming up as a line, didn't I? So I wasn't purposely trying to line them up, but I probably was subconsciously, would be my guess. Okay. And if you graph that, do you get a line?
Yeah.
You do. Now, when you go to type this in your graph, folks, remember, it's secant. So you can do 1 divided by cosine of theta, or you can do cosine theta raised to the negative 1 power. Mine's still zoomed in from the last graph, but it's a straight line.
Do we add arrows to it?
Yeah, you could. I mean, yeah. I don't know. More often than not, our graphs tend to be continuous, like the circles and other type shapes where they're just flowing and there is no end, so to speak. So I don't think about arrows, but. Okay, ready for the last one? Now, going back to my XY chart. What's different here? We're adding. So it's 1 plus sine theta. Now, so, I mean, did we already do a sine theta like our first graph? So really,
We just add to that.
you can, yes? On number 1, we already did sine theta. This is 1 plus sine theta. So like at 0, sine of 0 was 0. Plus 1 puts us at 1. Okay, I'll be honest, I have this one all in decimals. So sine of pi over 6 is 0.5, 1/2. You add 1, it's 1.5. Sine of pi over 4, well, that's at 0.707, so this is 1.707. Sine of pi over 3 is at 0.866, so this is 1.866. Sine of pi over 2 is 1. Add 1, you're at 2. Now, quadrant 2. Okay, it is positive. So are these values going to work out the same?
Yes.
In this quadrant, yes. Okay, in this quadrant, yes, because it's going to be 2 pi over 3, so it's going to be the 0.866 plus the 1. So these values are going to be the same. 3 pi over 4 is going to be the 0.707 plus 1. 5 pi over 6, 0.5 plus 1, so 1.5. Sine of pi is 0, add 1, you are at 1. Now, what happens in quadrant 3?
They're negative.
Sine is negative,
You add 1.
and we're adding 1 to that negative value. Am I just repeating these values and tossing a negative on them? No. This is a situation you can't, because it's an adding subtracting situation. Are you seeing what I'm doing here?
Yeah.
Okay, so you have to be aware that, I mean, yes, quadrant 1 was positive. Quadrant 2 was positive. So those were both adding. But now that we have a negative, it's going to turn into a subtracting situation. So 1 minus 0.5 is going to be, how about just positive 0.5? Right? 1 plus negative 0.5. On 5 pi over 4, well, sine of pi over 4 is the 0.707, so 1 minus 0.707. What is 1 minus 0.707?
0.293.
0.293. And then 4 pi over 3. 1 minus the 0.866. 0.134. Okay? Sine of 3 pi over 2 is negative 1. 1 plus negative 1 is 0. Now, what do we know about quadrant 4? They're negative. If we want to make it easy for ourselves, what are we doing here?
The same thing.
We can take our quadrant 3 ones, yes? Because it's going to be 1 minus each of those values. So, 0.134. What was that supposed to be? 0.293?
Yeah.
Swear I wrote the 3, but it's not there, so. And 0.5, 2 pi is 1. The sine of 2 pi is 0, plus 1 is 1. Okay. Different, yes? Part of the reason, as much as I want to say, hey, I just started homework. You got it. You got the idea. I need to show you that they do change up sometimes, don't they? Okay, so you have to be aware. Okay. Let me label this real quick. 0, pi over 6, pi over 4, pi over 3, pi over 2. 2 pi over 3, 3 pi over 4, 5 pi over 6. Pi. 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6. Okay? 0, 1. Pi over 6. Oh, that's not 1, is it? You guys probably aren't even watching me because it looks like you guys are ahead of me. Okay. 0, 1. Pi over 6, 1.5. Pi over 4, 1.7. Pi over 3, about 1.9. Pi over 2, 2. 2 pi over 3, 1.9-ish. 3 pi over 4, 1.7. 5 pi over 6, 1.5. Pi is 1. Do I get to just stop and everything repeats now?
No.
No. Okay, another reason I wanted to show this one, yes? 7 pi over 6, 0.5. 5 pi over 4, 0.3. 4 pi over 3, 0.1. 3 pi over 2, 0. 5 pi over 3, 0.1. 7 pi over 4, 0.3. 11 pi over 6, 0.5. And 2 pi is 1. Now, as you do these, because you'll have some interesting ones in homework, connect your dots in the order that you graph them. That is something to keep in mind. Okay, connect your dots in the order that you graph them. So as we do this, I mean, do you see what's happening here? I don't know what shape you want to call this. I mean, technically I would start here and go around, right?
I saw right. Or peach. No.
I don't know what you want to call it, but okay. What was this? 1 plus sign that?
Yeah.
So if you haven't already looked down on the graph,
Well, at first I didn't zoom in, so I just thought it was a circle. But then I zoomed it in.
yeah, I squared it and then zoomed it in to get it to look like that. Okay. So.
Oh, you dropped. These are gone. You dropped your pen.
Okay, guys. You have 6 questions. I have graph paper for you. Now, the graph paper, it's already labeled. You're probably going to want to do your XY charts on a separate sheet of paper unless you can fit them in. I don't know. You do you. Okay? And this homework, we will check tomorrow in your class, is my plan.
Yeah.
Okay?
That's not.